So this will be 14. I am going to call them super notes. Again, because of that, because they're so important. It's like the basic stuff, but really important basic stuff. Okay, these are called trig functions. Everything that we do today is from geometry. Okay, but it's so we're not going to redo geometry. It's just kind of touch base with geometry, and then we go deeper than that. Okay, but it's things you should have seen already. Okay, so let's begin. Trig functions are these. We have, this one's pronounced sine. Okay, sine of a certain angle equals opposite over hypotenuse. And we are going to talk about who is the opposite, who's the hypotenuse, and all that. We have cos, which is called cosine of a certain angle. This one's adjacent over hypotenuse. And then we have a tangent. Tangent of a certain angle equals the opposite over the hypotenuse. Okay, these are the three main ones. These are the three main ones we use. Nope, adjacent, sorry. Opposite over adjacent. These are the three main ones we'll use. So these are the three main ones you need to know. Okay, there's an acronym to know these because we're not going to write them on the wall. Okay, so you have to know them. But the acronym is really helpful. So, ca, tor. Okay. Honestly, when I went through school, I didn't know SOHCAHTOA. I just memorized them. But SOHCAHTOA is really helpful. Here's how it works. So if you remember SOHCAHTOA, you'll remember these. You just have to know how to read it in the order. So S, obviously, for sine. Okay. C for cosine. And T for tangent. So the first letter tells you which function to use. And then the next two letters go in this order. The second letter is the top one. And then the third letter is the bottom one. So that's important because I remember last year students would mix those up, right? So it's top, bottom. Top, bottom, top, bottom, top, bottom. It's just in the order that you read it, but it's the top and then the bottom. Okay? Does that make sense how to use the acronym, guys? SOHCAHTOA. Okay. And then we have these that are called reciprocal functions. My last period said they don't do this in geometry, so these might be new to you. Okay. Reciprocal means like the opposite of these, the flipped versions of these. They have their own names. Okay. And so this one, so first let me show you what I mean by that. It's like if you flip, so instead of O over H, it's H over O. Okay. Instead of A over H, it's H over A. And then instead of O over A, it's A over O. So that's what we mean reciprocal. Just flip. Now the names are weird, okay, especially if you've never seen them before. The one that's the reciprocal of sine is called cosecant. Wait, wrong. Trying to stick to the same colors. Cosecant. CSC. It's pronounced cosecant. And again, they're really new to you, but we're going to use them all semester, so you'll become more and more familiar. This one is called secant. And then the tangent is called cotangent, or cot. So we don't say cot, we say cotangent. Secant, cosecant. Okay, now I think tangent and cotangent, pretty obvious, right? Because they both have the letter T none of these have a T, so those are easy to figure out that they're opposites of each other. These are confusing, I think. Okay, who goes with who? So here's how I remember who goes with who. You would think that the first letter goes with the one that has the same, but it's not. It's the one that has the opposite. Okay, so S goes with C, and then C doesn't go with C. C goes with S. So it goes with the one that has the opposite letter. I don't know if that makes sense. That's how I remember who. It's the opposite letter. Okay. We good so far? Okay, for today's lesson, we're really not going to touch these that much, but they'll come back more. Okay, but I just wanted you to kind of know who they are. Okay, now here comes the really important part. So draw this triangle. So we're going to be dealing with right angles. Okay, right angles means you have an angle that's 90 degrees. That's what a right triangle means. And so you see this little square. If you see that little square, that means 90 degrees, which I know probably most of you or all of you know that. But again, just assuming you don't know anything about this. So that's a 90-degree angle. Okay. For today, that's all most of this unit, we're just going to be dealing with 90-degree angles. Again. Okay, guys, and let's call this angle theta. So the first part where this lesson will be easier, hard for you, is knowing how to decide who is H, who is O, and who is A. Just from last year, I remember students would struggle with that. So here's how I would suggest you do it. Whatever your 90-degree angle is, right across from it, okay, that's always going to be your hypotenuse. Because that's your longest side. That's going to be your biggest angle. Okay, so always do this one first. Put H, like see who's H. And you could literally measure it, and it's going to be always the biggest one, the longest one. It's always your H. Okay. The next one I would find is whatever angle you're focusing on. So like right now we're focusing on this angle. Opposite of that one, like opposite of it, is the opposite. That's your O. So whatever angle you're talking about, directly across from it, that's the opposite. I would always find this one second. And if you have those two, then just by common sense, right, the last one has to be adjacent. So I would do this one third. Just by default, that has to be your adjacent. That makes sense? Okay, so let's see. Draw this triangle that's upside down. And let's call this beta. Okay, so just put H, O, and A, just to see if it really does make sense. Who is H, who is A, and who is O? Because that's the first, crucial part. It's super easy for you to know who is who. Okay, so here we go. So again, I would do it in this order. H, across from the 90-degree angle. Opposite, across from the angle that we're focusing on. In this case, is beta. And then by default, another one is A. Is that good, guys? Does that make sense? We're good understanding that? Yes? Okay, good. I know it's easy, but we have to get that down. Okay, so here we go. Let's do example 1. And let's do this triangle. This is the right angle, this is 8, this is 4, this is theta. Okay, that says 4 square root of 5. That's a little weird to you at first. 4 square root of 5 is just a number. Okay, but when we're talking about why do we write that number that way. So first, just identify who's O, who is H, and who is A. Okay. So H. And I would do that on your papers every time. That way you don't accidentally do a silly mistake. Okay? So now that we have those, let's do the sine of theta, the cosine of theta, the tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. Okay, so I'll do the first one just to show you how it's set up. So sine is the opposite over the hypotenuse. Okay, so go ahead and fill the rest out. Okay, there they are, right? If you write them like that, like this is the opposite of this one, and then you just have to flip them, right? Because they're just the flip versions. Everybody okay with that part? We're good? Okay, let's reduce some of these fractions. We always reduce if we can. So for example, those 4s can become 1s, right? Because 4 and 4 divide by 4. This divides by 4 and 4, so that would become a 2. This divides both by 4, so that becomes the 1/2. We reduce them, right? Again, 1, that's just a 1. 2, and that equals to 2. So we reduce all our fractions if we can. Any questions, guys, so far? I know it's easy, but I'm just assuming like y'all don't remember any of this. Okay, we're starting from scratch. Okay, I'm gonna separate this part of the